Hello, in this video I will present you our remote lab called Arduino Remote Laboratory, or ARL for short. The lab consists of an Arduino board, mostly Unos, connected to various electronic components, and the whole setup is accessible via servers that are hosted at the Digital Systems and Media Computing Laboratory of the Hellenic Open University. First of all, since communication with the lab servers requires a web interface, all you need is a web browser. But ARL uses Flash and Java technology. Probably older versions of most web browsers will operate seamlessly with the lab, but this is not true for the latest updates of popular browsers like Firefox and Chrome. Hence, in such cases, we recommend that you use an oldie, the IE, the old Internet Explorer, which exists in all Windows installations. You can find it here. Type IE, and even in a brand new Windows 10 installation, you will find the Internet Explorer. Especially for Java, you should not forget to add the ARL servers at the Site Exception list in Configuration tab. Find Configure Java, go to the Security tab, and here is the exception site list. I've already added two IPs here, as you can see. Actually, there are 5 different IPs serving ARL, but 4 of them host the same basic coding examples. The Arduino board that is connected to the server with IP address 110 is also connected to the internet via an Ethernet SILD in order to practice IoT examples as well. So, after this introduction, we're ready to use our lab. Now, let's use our browser to connect to server 107. Here we are at the URL bar. And this is the first page of the ARL installation. From here, you can register for a new system account or use your login credentials to enter the lab. In the registration form, a minimal amount of data is required, so it won't cost you more than a minute to create a new account. I will use my own credentials to log into the system for now. And here we are. This next page that shows up is the reservation page. From here, you can check your reservation schedule or create new reservation and delete them. To create a new one, first you select the date. Let's make it today. Then you select a 1 hour time slot. Let's choose the current. And then you press the plus sign and your reservation was created successfully. You can see it here. You can also create future reservations. For example, let's make one for tomorrow. You see that for this time slot, the current time slot, there's only a green lock here that you can press to enter the lab. But for future time slots, you can also delete them by pressing the trash can or edit them by pressing the range key. Now, let's press the green lock to enter the lab. So, this is the main lab page. There are 4 sections here. First, we have the section management part. This section shows information about the user, the current active reservation, and remaining time. When time is close to expire, notifications pop up in the page informing us about the remaining minutes. In the coding area, this is the place where we write our own Arduino code, or we can use one of the 7 already available sample code. Just press the plus sign here and you can select whichever you like. I'll choose Lab 1, the blinking LED, and the sample code appears in the editor where you can change it as you like. However, you should always remember that the ARL components are already connected to the Arduino board. If you press the lab diagram link here, those connections will appear. Thus, it is obvious that you can't run the blinking LED code for pin 12, which is here, the blue wire, because this one is connected to the LCD, as you can see, not to the red LED, where only pin 13 is connected. The sample code, all of the sample codes here, are always taking into account the existing connections. But if you're writing your own code, please study the diagram with the connections first. If you press the compile button, then you will see the compilation results in the area below the editor. We're expecting the results here. If everything is okay, like now, a green notification appear in the area, along with the program and variable size. If not, the notification will be red and the errors appear in this area. Now, if we also check the upload checkbox, then right after a successful compilation, our board is programmed, and then we can see our results in real time from the video we do, which is the last area in this page, here. You can even maximize this area if you like to see the video in full screen. You can clearly see now the red LED blinking. Actually, you can change the code in order to make the LED blink faster or slower. Let's change the delay from 1500 to only 500. That will make it blink faster. Let's check. We're waiting for a while for the compilation to end. Now that fast blinking means the board is programmed, and you can see now that the LED is blinking much faster than before. You can realize now that whatever change to the code you make in the editor area makes the board behaving accordingly, as you can see in the video. You can check other code samples as well. For example, you can use Lab 2 to see the RGB LED changing colors. Let's have a look. Compiling goes on. Let's maximize. Programming takes place here, and now the RGB LED will start changing colors, as you can see. You can change the way that colors change to see whatever color variations you like. Or you can check another code to print messages on the LCD screen. Let's see the results here. Programming. And now you see a counter running on the LCD display. Very well. You can even change the message that appears on screen. Let's change the first, for example, line. Compiling. We could also change how fast the numbers appear in the screen. Another compile, and now I'm going to check my result when this goes green. Okay. Yes. Now our LCD shows hello in the first line of the display, and the counter is changing much faster than before. Very well. You can also work with the servo motor with Lab 4. Let's try it. We're expecting to see the RX TX LEDs change rapidly, and now that our program has been downloaded, you see the servo motor turning in the video. You can even make modifications. For example, you can change this loop in order for the servo pause to change not only 1 degree each time in the loop, but 5 degrees in both ways, in both directions of the rotation. So now, if I compile, I will see that when the code is downloaded, the servo will turn faster than before. Now it is programmed. Look. Much faster. In both ways. Okay. You can always reset the Arduino in order to upload a blank code so that the previous code stops running. And let's see other examples. You can read analog values with Lab 5 and Lab 6 sample codes, one from the LDR photoresistor and the other one from an LM35 temperature sensor. But for these two, you have to use the serial monitor, and this is where Java comes in. So let's make an example. Let's use the LM35 temperature sensor. We will compile and upload our code, but as you see in this code, the calculated temperature variable LM35 Celsius is printed in the serial console. That means we need to see the console, the serial terminal. So in this case, after the code is uploaded, we press serial monitor here, and then we get the security warnings about Java. We have to accept the risk, run the applet, again don't block this applet, and again run to finally see this small terminal that shows us the lab temperature every 1000 milliseconds, that means 1 second, and so we know that we have almost 25 Celsius degree temperature in the lab room. Similar is exercise number 5, which displays the value from a photoresistor in the serial monitor. Let's run it. Again, we press serial monitor. There are no questions this time because we answered it previously for the temperature sensor. And you can see that we have a value that comes from the LDR almost close to 200, 119, something like that. Since I'm close to the room, I'm going to close the lights to see if there is some change in the value. Just a second. As you can see, the LDR values now have changed significantly. We can even combine codes. For example, I can use the code from lab 7, which is a counter running that shows its value on these two 7-segment displays, to, for example, show the integer part of the temperature. But first, let's see lab 7 alone, the counter that runs on the 7-segment displays. I'm going to light the lights again for a moment. Okay, here we are. As you can see, a counter runs and adds 2 every time. As it's counting up, it stays to 99 for a brief moment, and then it starts counting down again by 2. So one can combine the code between, for example, lab 7 and lab 6 to display the value, the temperature value on the 7th segment. So let's do so. I'm going to get this part, these 2 lines of code, this one is comment, and copy them to the lab 7 code. So inside the loop, I will read the value of the sensor. I have to declare it first, of course. And float value for LM35 Celsius. And I will skip most of this code. I will not need all this. And I will put here, instead of counter, the integer value. I'm doing some casting here of LM35 Celsius. I think it's okay. Let's skip all this. And I think we are ready. Let's try, compile and upload. A reminder about time running up. And here we have a problem, what I've told you before, that if you have compilation errors, then you get a red notification here. If you press on the link of the error, it will show you where exactly in the code is the problem. It seems here that I missed a parenthesis, so I will put another one. And now that I see it, I forgot two more lines from the original code. Let me open it once more. Nope, it disappeared. Okay, it doesn't matter. I will again take those two lines over here, not from lab 5, from lab 6. Here they are. Copy, go again to lab 7, delete all these here, but keep those two, and then I will paste this, delete the loop, I don't need it, and I don't need all of the rest of the loop until that one. So now I just need to define the variables inside the loop, and again go here and change this counter value to integer casted. Now I don't forget the parentheses. LM35 Celsius. Now we're ready. Compile, upload. Hope there's enough time before we are automatically logged out. Okay. Compilation has finished. Sorry, wrong button. And here we are. 24 to 25, because probably we're close to 24.5. Celsius in the lab. So with rounding or truncation, it goes to this value. So you've seen that a combination of codes worked very well. There are many things that you can do with this experimental setup. You can combine lots of code samples from the already available, or you can write code from scratch on your own, as earlier said. So if you like what you see, please have also a look at server 110 to see 4 more experiments with the addition of network connectivity for IoT testing. Thank you for watching this video.